Hello, good morning, my dear children. I hope everyone is safe and sound. All right, I welcome you all back again to my physics class. As you are all are aware, we are doing chapter number 3, laws of motion, isn't it? Okay, so in this laws of motion, we have learned unit A, where we have learned forces, types of forces, contact and non-contact forces. In unit B, we learned about Newton's first law of motion. In unit C, we learned about Newton's second law of motion. And in unit D, we learned about Newton's third law of motion, isn't it? Newton's first law gave us about the qualitative nature of force. In second law, we learned about the quantitative nature of force. And in third law, in the last class, we learned about action and reaction of a force. Today, we are going to do the last unit of the chapter, and this is going to wrap up your chapter number 3. Unit E is the unit which deals with gravitation. Alright, so now today we are going to discuss about this unit, that is unit number E from your chapter number 3, laws of motion, that is gravitation. And today's video will be the last video from this chapter, chapter number 3. Okay, let's begin. Unit E, gravitation. Now what is gravitation? Now gravitation is nothing but a force, okay, which is exerted by a body. It can be any body means anything, like your earth, like us, like table, chair, school, building, okay, books, whatever the things. So Newton found out that whenever two particles, suppose say these are the two particles, okay, particle A and B, or you can say two bodies A and B, having the masses m1 and m2 separated by a distance d, they attract each other. This attraction, the force of attraction, is actually what? Gravitation. Are you getting my point? So these two bodies A and B, whose masses are m1 and m2 separated by the distance d, okay, or sometimes it is referred as r also, distance la r pani bhन्छ कोही बेला, okay, is known as gravitation. That is the definition. Now mathematically, this gravitational force is denoted by capital letter F, okay, where F equals to G m1 into m2, that is the mass of the first body with the multiplied by mass of the second body divided by the distance square, or square of the distance between them. And where this G is called the gravitational constant. We call this as universal gravitational constant. यसलाई के भन्दो रहेछ? यो G लाई चाहिँ universal gravitational constant. And what is this m1? m1 is the mass of the first body. What is m2? m2 is the mass of the second body. What is r? r is the distance between the two bodies, center of the two bodies. All right, so this is the formula, okay, to express the gravitational force. So gravitational force खोज्ने formula चाहिँ यो, okay, that is F equals to G m1 m2 by r square. And what is this G? G is universal gravitational constant. It's a constant, okay. You will learn these things in much detail in the higher classes. Now what is the value of this G? Numerical value of G चाहिँ कति हो भन्दाखेरि चाहिँ the value of G is 6.67 into 10 to the power minus 11 Newton meter square per kilogram square. So you need to know this, mark this, okay. So it's an important one. I may ask you in the test or in the exam. So this is your gravitation, and gravitational constant. All right. Now the next that we are supposed to discuss here is acceleration due to gravity, that is g. We have used this g several times, isn't it? This g means acceleration due to gravity. Now what is gravity? Gravity is the force by which earth pulls an object, isn't it? So here earth is an object, what body, okay, one body, and whatever it is pulling, that is the second body. So the force what experienced between these two bodies is called gravitation, isn't it? So this gravity means the force which is creating or causing the acceleration, okay, which is causing the acceleration on the body is called acceleration due to gravity. Acceleration, जुन चाहिँ acceleration चाहिँ ग्राभिटीले गर्दा भएको छ, there is a change in the velocity due to the gravity, the force by which a body is pulling another body, or you can say an object is pulling another object. त्यो acceleration like that we call it as acceleration due to gravity, which is denoted by small letter g. What is it? Small letter g. Is that okay? Yes? Alright. Now, the next topic now you need to discuss here is mass and weight. Very important topic, because till now you are confused that these two are not same physical quantities. Mass and weight are not same physical quantities. Are you getting my point? Did you understand here? So mass and weight are not same. They are two different things. Now what is mass? Mass means amount of matter. You know, everything is made up of matter, isn't it? So amount of matter which is contained in a body. एउटा बडीमा कति त matter छ, त्यसलाई त भन्छ mass. So mass is the amount of matter contained in a body. It is scalar quantity. When we say scalar quantity, it has only magnitude. Only the magnitude, no direction. Are you getting my point? Yes. Now its SI unit is kilogram, abbreviated as kg, and its CGS unit is gram, where 1 kilogram equals to 1000 gram. Is it understood? Yes. Okay. Now the other one is weight. Now what is weight? Now weight is the force. See, weight भनेको चाहिँ के रहेछ? Force रहेछ. Now what is weight? Weight is the force, okay, with which earth pulls an object. Pulls an object. Earthले कतिको forceले त कुनै पनि objectलाई pull गर्छ. Measure of that force is called weight. It is a vector quantity. So weight is a vector quantity. Alright. So it means that it has both magnitude. It has both magnitude and direction. Okay, अघि हाम्रो mass को त के थियो? It was a scalar quantity. It has only the magnitude, no direction. But weight, it has a direction that is always downwards. Understand? It always acts in the downward direction. Now let's learn about its units. SI unit of weight is Newton, since it is a force, so it will have the same unit as that of force. Whereas CGS unit of force, that is weight here, is dyne, and relationship between them you must know that 1 Newton is 10 to the power 5 dyne. 10 to the power 5 dyne is the relationship between the SI unit of weight to the CGS unit of weight. Now let us learn the last relation between mass and weight. Mass ra weight ko relation. So if I represent weight of an object with W and mass of an object with M, then weight is given by the product of mass into acceleration due to gravity, that is W is equals to mg. This is a very important relation to find weight. Okay, so you can find the weight of an object like this. So suppose, see, my mass, मेरो mass त कति हो? 75 kilogram, and acceleration due to gravity is approximately taken as 10 meter per second square. So what will be the force? What will be my weight? My weight will be W equals to 75 into 10, because m into g, this is our relation. So m is 75, g is 10, so 75 into 10 is 750 Newton. So my weight, मेरो weight चाहिँ कति रहेछ 750 Newton, मेरो mass चाहिँ कति रहेछ 75 kilogram. So please you make up your mind clear now that mass and weight are different, two different physical quantities. They are not similar, okay? They are totally two different physical quantities. Mass is the amount of matter contained in a body, whereas weight is the force by which earth pulls an object towards it, okay? Mass is a scalar quantity, weight is a vector quantity. Clear? SI unit of mass is kilogram, whereas SI unit of weight is Newton. Similarly, CGS unit of mass is grams, okay, whereas CGS unit of weight is dyne. Please remember this. Okay, so now let's discuss the last topic from this unit, that is gravitational units. What is it? Gravitational units. Okay, in MKS system, gravitation को के हुन्छ MKS र CGS हुन्छ. SI को त sorry, standard units को त के थियो SI र CGS हुन्छ नि. So in MKS system it is kilogram force written as kgf. In CGS it is gram force. So gravitational unit कसको यो force को. Gravitational unit of force is kilogram force in MKS sorry, and gram force in CGS. Are you getting my point? Yes. Okay, where 1 kgf भनेको चाहिँ is how much? It is 9.8 Newton. 1 kgf भनेको चाहिँ कति रहेछ 9.8 Newton, which sometimes we approximate it as 10 Newton. Similarly, 1 gram force, okay, is how much? 980 dyne. So please remember this too. Okay, 1 kgf means 9.8 Newton or 10 Newton, okay, and 1 gram force equals to 980 dyne. Okay, so we'll be now getting the notes as usual, okay, as I used to give you all. Copy the notes in your copy properly and learn them too. Alright, so this is it for today. Okay, so I hope you all enjoyed this session. If you have any doubts, any queries, please do let me know in the class group, or you can always text me personally, okay, to make your doubts clear. Alright, so that's all for today. Thank you.